The fuel gauge was falling. Second Lieutenant William Roach could feel it in his gut before his eyes even confirmed what the instruments were screaming at him. November 7th, 1943. Somewhere over the patchwork quilt of occupied France, his Pratt and Whitney engine began to cough. The headwinds over the channel had been brutal, unforgiving. They'd drunk his fuel like a thirsty animal. He had maybe minutes. Below him, the French countryside unrolled in shades of brown and fading green. Fields, farmland, and scattered among them, airstrips. He spotted one that looked right, familiar even. The layout was perfect. American standard, clean taxiways, organized parking areas. Roach committed. His Republic P-47D Thunderbolt, serial 42-22490, call sign Beetle, dropped from the grey European sky. The wheels kissed grass, smooth, professional. He taxied behind a ground vehicle, following it to a parking area like he'd done 100 times before. Then he cut the engine and saw the crosses black, angular, painted, on wings that should have carried stars. The rifles came. Next, German soldiers materialized around his cockpit, muzzles pointed, voices shouting in a language that wasn't his. Lieutenant Roach's hands went up slowly. His war as a fighter pilot ended in that moment. He'd spend the next year and a half behind wire at Stalag Luft 1. But for the Luftwaffe, the education was just beginning. They thought they understood American fighters. They'd been wrong about everything. The Germans had been fighting Thunderbolts since April of '43, when the massive American fighters first appeared over Europe, escorting those endless formations of B-17s into German airspace. Luftwaffe pilots had laughed. The thing was absurd. A beast. Grotesquely large for a single-seat fighter. It wallowed at low altitude like a transport plane. Its rate of climb was pathetic. German combat reports from those early months read like comedy. Pilots accustomed to the razor-edge agility of the Focke-Wulf 190 and the Messerschmitt 109 couldn't believe what they were seeing. The Americans had built a fighter that seemed designed by engineers who'd never seen aerial combat. It was slow to climb, ponderous in turns. The American pilots refused to dogfight at medium altitude, where any competent German pilot could carve them to pieces. The assessment was clear. Inferior design. Typical American engineering. All brute force, no finesse, but there were details in those same reports that didn't quite fit. Pilots mentioned that when Thunderbolts chose to leave a fight, they simply vanished. They'd roll inverted and dive, and suddenly they were gone. Unreachable. German fighters that tried to follow found their controls locking up, their aircraft shaking apart as they chased ghosts through compressibility. They mentioned 8 machine guns, heavy 50s. When those guns opened up, the effect was biblical. They mentioned armor that swallowed their bullets. 20mm cannon shells that should have shredded an aircraft punched holes and did nothing. Thunderbolts came home, missing sections of wing, engines streaming oil, control surfaces shot to ribbons, and still flying. Still alive. When Beetle rolled to a stop at Beaumont-le-Roger that November morning, the Luftwaffe finally had their chance to understand why. The plane was immediately surrounded, guards with rifles, officers barking orders. Within hours, American markings vanished under coats of German paint. Black crosses bloomed on wings and fuselage. The undersides and tail received bright yellow paint, RLM-04 yellow, the Luftwaffe's signature for captured aircraft. A warning to their own gunners. Don't shoot this one down. The aircraft received a new designation. T9 plus FK, Zircus Rosarius. The evaluation unit, they transferred the Thunderbolt to Rechlin, the Luftwaffe's premier testing facility northwest of Berlin. The man assigned to fly it was Hans Werner Lerche, the facility's chief test pilot. Lerche would fly 125 different aircraft types during the war without crashing a single one, not once. His safety record was supernatural. But when he climbed into Beetle's cockpit for the first time, even Lerche paused. The instrument panel was a maze, gauges everywhere, twice as many as any German fighter. Levers controlling systems he'd never encountered. The turbo supercharger system alone required understanding principles that existed mostly in theory in German aviation circles. The constant speed propeller, operated on entirely different logic than German. Equivalence. And then there were the mysterious controls whose purpose he couldn't even guess. Lerscher spent hours on the ground, studying, testing switches, mapping the cockpit in his mind. He approached the Thunderbolt like a scientist approaching an alien artifact. Careful, methodical, respectful of what he didn't know. The engine start sequence was elaborate. The Pratt Whitney R2800 Double Wasp required specific procedures to wake up its turbo supercharger system. Lerscher followed each step, his engineer's mind cataloguing, inferring, understanding. When all 18 cylinders roared to life, the sound was unlike anything in the Luftwaffe inventory. Not the sharp bark of a Daimler-Benz, inline. Not even the familiar rumble of a BMW. Radial. This was deeper, heavier. A sound that suggested vast reserves of power held barely in check. Lerscher taxied carefully. The weight was immediately apparent. 10,000 pounds empty, with fuel and ammunition closer to 13,500. For comparison, the Focke-Wulf 190, one of Germany's heaviest fighters, weighed 7,600 pounds empty. The Thunderbolt was genuinely massive. Larger than some twin-engine aircraft Germany fielded, he advanced the throttle. The R2800 developed 2,000 horsepower at standard boost. With water methanol injection, it could push 2,300. Germany's finest radial, the BMW 801, made 1,700. Maybe 1,730 on a good day. The takeoff roll consumed nearly the entire grass field, but once airborne, everything changed. Below 15,000 feet, the Thunderbolt was exactly what German pilots had described: heavy, sluggish, unable to match German fighters in a turning fight. The rate of climb was mediocre at best. At this altitude, any competent Luftwaffe pilot could dance around the American fighter. But Lerscher kept climbing, and somewhere above 20,000 feet, the aircraft transformed. The turbo supercharger, driven by exhaust gases, became increasingly efficient as the air thinned. While German engines gasped and wheezed and lost power with altitude, the R2800 kept producing full-rated output. At 25,000 feet, where German fighters operated at maybe 70% power, the Thunderbolt's engine was still singing at full throat. Lurch pushed the throttle forward. The big fighter accelerated with shocking enthusiasm. He rolled into a dive to test high-speed handling, and the Thunderbolt responded with violence. It accelerated past 500 miles per hour. The controls stiffened as airflow compressed around the airframe. At this speed, pulling out of the dive required both hands on the stick and every ounce of strength in his arms. The aircraft was approaching the edge of compressibility, the threshold of the unknown that wouldn't be fully understood until jets arrived. But the roll rate stunned him. Despite its bulk and weight, the Thunderbolt rolled faster than any German fighter he'd flown, faster than the Focke-Wulf 190, which was considered excellent. This characteristic, combined with its devastating dive speed, created a tactical advantage that finally made sense of the combat reports. An American pilot in trouble at high altitude could simply roll, inverted and dive away. No German fighter could follow. Any Luftwaffe pilot attempting pursuit would hit compressibility effects that his aircraft couldn't handle. The Thunderbolt's stronger airframe and more effective controls dealt with these forces better. It could go where German fighters couldn't. Lersch flew the captured Thunderbolt through exhaustive testing at altitudes above 25,000 feet, where the air war was increasingly being fought. The P-47 wasn't inferior to German fighters. It was superior, in ways that mattered. Over the following weeks, Rechlin's engineers tore Beetle apart. They photographed every component from every angle. They measured dimensions with precision instruments. They weighed every major assembly. They tested every system under varying conditions. The Sieg-Gorn turbo supercharger received special attention. This technology represented the fundamental difference between American and German approaches to high-altitude performance. What they discovered shocked men accustomed to resource-constrained design. The Pratt Whitney R2800 Double Wasp consisted of 18 cylinders, arranged in 2 rows around a central crankshaft. Total displacement, 2,800 cubic inches, 46 litres. But displacement alone didn't explain the power difference. The engine incorporated forged aluminum alloy pistons, sodium-cooled exhaust valves to handle extreme temperatures, a crankshaft forged from high-grade steel alloy that German metallurgists examined with something like envy. These were materials Germany could no longer obtain in sufficient quantities. The quality was what stunned them. Every component showed precision manufacturing to tight tolerances. Surface finishes were consistently smooth. The magnetos used materials increasingly scarce in Germany. The spark plugs incorporated ceramics superior to German equivalents. The fuel injection system operated with laboratory equipment precision. Nothing showed material substitution. Nothing reflected the desperate improvisations that characterized late-war German production. The Americans had built this engine exactly as designed, using all specified materials. No compromises, no shortcuts, no substitutes forced by scarcity. The untold turbo supercharger system revealed sophistication that Germany had attempted but never successfully implemented. Exhaust. Gases from all 18 cylinders were collected through manifolds and routed through insulated pipes to a turbine unit behind the cockpit. This turbine, spinning at tremendous speed, drove a centrifugal compressor that forced additional air into the engine's supercharger. The system included an intercooler to reduce compressed air temperature. Automatic regulators controlled boost pressure without constant pilot intervention. German engineers understood the theory perfectly. They'd conducted experimental programs. But implementing such a system in mass production had proven impossible. The turbo supercharger required exotic high-temperature alloys for turbine blades, precision manufacturing, reliable components, extensive ducting with perfect seals. Every element had to function reliably in combat conditions, exposed to vibration. Temperature extremes from -60 Fahrenheit at altitude to over 200 near the engine. Potential battle damage. The Americans had solved all these problems and installed the system as standard equipment on every P-47 produced. Not experimental equipment for special missions. Not limited production runs. Standard equipment. This casual implementation of advanced technology revealed industrial capacity German engineers found difficult to comprehend. The technical reports from Rechlin noted that the turbo supercharger system alone exceeded current German capacity to replicate in production quantities. The materials, the precision manufacturing, the quality control required to produce such systems reliably at scale. Germany simply couldn't do it in 1943. Not with strategic material, shortages, not with Allied bombing degrading manufacturing standards. Not with skilled workers being replaced by forced labor. The armament. Installation provided another lesson in American abundance. 8 Browning M2 machine guns, 50 caliber, 4 in each wing. Most German fighters carried mixed armament, typically 4 machine guns and 2 20mm cannons, or 6 machine guns total. The American decision to install 8 heavy machine guns represented a deliberate choice to maximize firepower, even at the cost of weight and complexity. Each gun fed from a separate ammunition box built into the wing. Structure: 425 rounds per gun. 3,400 rounds total. For comparison, the Focke-Wulf 190 typically carried 2,000 rounds total for its machine guns and 500 for its cannons. The P-47 pilot could fire all 8 guns continuously for approximately 20 seconds. The combined rate of fire approached 100 rounds per second. When all 8 guns were harmonized to converge at a single point, the volume of fire was overwhelming. German test firings documented the devastating effect. The installation quality impressed armament specialists. Each gun was mounted in an electrically heated bay to prevent freezing at high altitude, where temperatures could drop to -60 or lower. Spent cartridge cases and belt links were collected and ejected through ports, preventing them from damaging the aircraft. The system functioned flawlessly during Rechlin testing. thousands of rounds fired. No jams, no feeding malfunctions. Even the ammunition quality revealed American industrial capability. The 50 caliber rounds used armor-piercing cores manufactured to consistent specifications, incendiary compounds that functioned reliably, tracer elements that burned predictably. American ammunition was more reliable than German production, which had suffered quality degradation as strategic. Materials became scarce. The Thunderbolt's armor protection demonstrated American willingness to accept weight penalties in exchange for pilot survivability. The cockpit was surrounded by heavy armor plate on multiple sides. The pilots sat in what American designers called an armored bathtub. Protection from below, protection from behind. The windscreen incorporated thick bulletproof glass capable of stopping machine gun rounds and resisting cannon shell fragments. Additional armor protected critical systems. Oil coolers. The vulnerable turbo supercharger. Total armor weight exceeded 200 pounds. German fighters typically carried less comprehensive protection. They prioritized lighter weight and better performance, while accepting higher pilot casualties as an unavoidable cost of combat. The other design philosophy difference revealed itself in maintenance. Accessibility. American designers had anticipated that mechanics would need to service aircraft quickly in forward bases, possibly at night, possibly in bad weather, possibly under threat of attack. Every major component could be accessed through large panels with quick-release fasteners requiring only simple tools. The massive engine could be changed in the field within hours. German fighters, designed with the expectation of factory-level maintenance, typically required more extensive disassembly. This reflected American abundance versus German scarcity. The Americans could afford to dedicate engineering resources to maintainability because they're industrial. Capacity allowed optimization for operational efficiency, rather than pure production efficiency. Perhaps the most profound revelation came not from any single system, but from the cumulative impression of quality throughout the aircraft. Every component appeared to be the best possible version American engineers could design and manufacturers could produce. Nothing was compromised due to material shortages. Nothing showed substitute materials. Nothing reflected desperate improvisation. German technical reports emphasized this repeatedly. The P-47 had been built exactly as designers intended, using all specified materials, all specified processes. No compromises forced by resource scarcity. This manufacturing fidelity to original design was becoming increasingly difficult for German industry. As the war progressed, the flight testing continued. Through winter and into spring, more P-47s were captured. On May 29, 1944, Second Lieutenant Lloyd Hathcock of the 332nd Fighter Group became disoriented during a ferry flight and mistakenly landed at the German-held Rome Littorio airfield in Italy. His aircraft, serial 42-75971, was quickly seized. The Germans transferred it to Rechlin, eventually to Circus Rosarius with designation T9+ LK. The testing data accumulated into tactical recommendations distributed to frontline fighter units. Engage P-47s below 15,000 feet where German fighters held advantage. Never dive away from attacking Thunderbolts, as they'll simply accelerate to unreachable speeds. Don't assume a few hits will down the aircraft. Damaged P-47s frequently continue flying. Attacks must be pressed home, aggressively. But tactical advice couldn't address the fundamental strategic problem. Germany was fighting an opponent with effectively unlimited resources. Every damaged or destroyed P-47 was replaced within days from production exceeding 300 aircraft per month. American pilot training produced skilled aviators in quantities Germany could no longer match. Training was compressed. Fuel shortages limited flight hours. The logistics system supporting American operations delivered fuel, ammunition, and spare parts without constraint. German logistics deteriorated under relentless Allied air attack. The captured P-47s were transferred to the Wanda Circus Rosarius. The special demonstration unit commanded by Hauptmann Theodor Rosarius traveled to Frontline bases throughout occupied Europe. German pilots could see captured Allied aircraft firsthand. Learn recognition features. Study combat characteristics. The demonstrations served dual purposes: educational and psychological. Pilots learned visual recognition and tactical characteristics, but they also saw physical evidence that Allied equipment was often superior in specific important capabilities, particularly at high altitudes where combat increasingly occurred. Post-war interviews with Luftwaffe pilots who attended these demonstrations revealed psychological impact. While Circus Rosarius pilots could show, German fighters maintained advantages in certain flight regimes, particularly at medium altitudes. The demonstrations made clear that at the altitudes where American bomber formations operated, German fighters were at distinct disadvantage. The intelligence gathered included detailed performance data that contradicted optimistic assumptions. At sea level, the P-47D achieved maximum speed of approximately 350 miles per hour, not impressive compared to the Focke-Wulf's 408. At 10,000 feet, the Thunderbolt reached 375. But at 30,000 feet, the P-47 achieved 426 miles per hour. The Focke-Wulf struggled to reach 370. The Messerschmitt 109G managed 385. The performance advantage at combat altitudes was clear, decisive, growing. More important as Allied bombers flew higher, service ceiling comparisons proved equally discouraging. The P-47 reached 42,000 feet. German fighters rarely operated effectively above 35,000, and their performance degraded rapidly higher due to reduced engine power. American bomber formations operated at altitudes where German interceptors could barely reach them, where interceptors that did reach combat altitude had insufficient power for effective maneuvering. The P-47 escorts operated comfortably at these altitudes, maintaining full combat capability while German fighters struggled. Range comparisons revealed another dimension of American superiority. With external fuel tanks, the P-47D could escort bombers deep into Germany. Early models had limited range, but by 1944, Thunderbolts with drop tanks routinely flew missions covering 1,000 miles or more. German fighters designed for short-range interception lacked internal fuel capacity for extended operations. The difference meant American fighters could engage at times and places of their choosing. German fighters were forced to fight defensively. The captured Thunderbolts also provided insights into American training and doctrine through examination of gun camera footage and combat damage patterns. The evidence suggested American pilots consistently employed tactics emphasizing the P-47's strengths while avoiding its weaknesses. They maintained high altitude, where the turbo supercharger provided advantage. They used dive and zoom attacks rather than sustained turning dogfights. They worked in coordinated pairs or four-ship flights, maintaining mutual support even when it meant declining apparently advantageous individual engagements. The discipline impressed Luftwaffe analysts. Many Luftwaffe pilots, particularly experienced aces, preferred individual combat, relying on personal skill and aggressive tactics. American pilots followed established doctrine consistently, supporting each other systematically, rarely allowing individual pride to override tactical sense. This disciplined approach, combined with superior high-altitude equipment and growing numerical advantage, created a combination veteran German pilots found increasingly difficult to overcome. By D-Day, June 1944, the strategic situation had deteriorated to where intelligence on captured aircraft provided little practical value. The Luftwaffe understood American equipment was superior in important ways. They comprehended American tactics. They had detailed technical data on performance, but knowledge couldn't produce the resources, materials, manufacturing capacity, and trained personnel needed to compete. The Rechlin reports, carefully compiled and professionally distributed, served primarily to document the technological and industrial gap driving Germany toward inevitable defeat. The comparison between American and German engine production illustrated the impossible position. Pratt and Whitney, along with Ford Motor Company, produced over 125,000 R-2800 engines by war's end. Production of this single engine type exceeded Germany's entire combat aircraft engine production. BMW produced approximately 61,801 radial engines throughout the war. The Daimler-Benz DB605, Germany's most produced inline engine, reached 42,400 units total. American production of one advanced engine surpassed Germany's total output of all combat aircraft engines combined. American industry in 1944 produced approximately 96,000 aircraft. Germany reached 25,000 of all types. The United States produced 38,000 fighters alone, plus 16,000 heavy bombers, plus thousands of medium bombers, transports, trainers. When combined with British and Soviet production, Allied advantage exceeded 5-1. The industrial base supporting this operated on a scale Germany couldn't match. The Aluminum Company of America alone produced more aluminum than Germany's entire aluminum industry. Individual American steel plants outproduced the entire Ruhr industrial region. Automotive factories manufactured on moving assembly lines, where German plants used batch production. Even the machine tools that built the machines that built the aircraft were produced in quantities allowing America to supply its own requirements and substantial quantities to British and Soviet allies. The captured P-47s ended their service in the chaotic final months. The aircraft, designated T-9+FK, originally William Roach's Beetle, was recovered by American forces at Göttingen in May 1945. Found among a collection of captured Allied aircraft the Germans had been evaluating. Photographs show the aircraft still wearing partial German markings, parked alongside Focke-Wulfs and Messerschmitts, a museum of captured equipment documenting the breadth of Luftwaffe intelligence gathering. The Thunderbolts that served German evaluation units provided an education desperately needed but received too late to matter strategically. The aircraft demonstrated that American industrial philosophy prioritized absolute capability over elegant efficiency, abundant resources over careful optimization, systematic material advantage over individual technical excellence. These priorities, when implemented with nearly unlimited resources and manufacturing capacity, produced weapon systems that outclassed German equivalents in aggregate, even when German designs showed superior characteristics in specific parameters. The lesson extended beyond the P-47 itself. Every category of captured American equipment told the same story. The B-17 Flying Fortress, with its quartet of turbo-supercharged engines, represented strategic bombing capability Germany never achieved. The P-51 Mustang, combining American airframe engineering with the British Rolls-Royce Merlin, created what many consider the finest piston engine fighter of the war. The P-38, Lightning with twin turbo-supercharged engines, demonstrated American willingness to pursue unconventional solutions. Each aircraft revealed the same approach: solve problems through superior engineering supported by unlimited industrial capacity, rather than clever optimization constrained by scarcity. Luftwaffe analysts clearly observed they weren't being defeated by superior tactics or better trained pilots. Though American training programs were producing adequate pilots in overwhelming numbers, they were being defeated by an industrial system that could design adequate equipment and produce it in quantities rendering German qualitative advantages increasingly irrelevant. Americans designed to their industrial strengths, leveraging massive manufacturing capacity, abundant raw materials, efficient logistics. Germany, by 1943, was designing despite crippling industrial limitations, attempting to achieve, through engineering cleverness, what they could no longer accomplish through industrial might. The strategic implications were documented throughout Luftwaffe technical services. Germany had entered the war with arguably the world's most advanced air force, aircraft generally superior one-on-one, pilots better trained initially, tactics more refined. But German industry fundamentally lacked capacity to sustain these advantages when facing opponents with vastly greater industrial resources. American aircraft production doubled repeatedly. In 1940, again in 41, again in 42, continued expanding until by 44, American factories produced over 96,000 aircraft annually. Germany never exceeded 40,000 in any year, despite desperate efforts. The quality gap widened steadily rather than narrowing. In 1942, German aircraft were often superior. By 1944, American aircraft equaled or exceeded German designs in virtually every category. By 1945, the gap had become a chasm. American fighters like the P-51H and P-47N represented evolutionary refinement of already excellent designs. German fighters like the TR-152 represented desperate attempts to extract more performance from industrial systems collapsing under combined weight of strategic bombing, raw material shortages, and replacement of skilled workers with poorly trained forced labor. The psychological impact on Luftwaffe morale proved as destructive as material losses. German pilots reported feeling less like warriors in honorable combat and more like targets in systematic destruction. No matter how many Allied aircraft they shot down, more appeared the next day. No matter how skillfully they fought, American numerical superiority eventually prevailed through attrition. The knowledge that their opponent's equipment was often superior, delivered in far greater quantities, supported by better logistics, and flown by adequately trained pilots who were quickly replaced when lost, created pervasive sense of inevitable defeat spreading through fighter forces during 1944. The captured P-47s served as tangible physical evidence, not propaganda claims or exaggerated intelligence reports, actual aircraft. German pilots could examine directly. The Thunderbolt wasn't some miracle weapon or revolutionary breakthrough. It was simply a very good fighter aircraft, properly designed for its mission, adequately powered, well-armed, appropriately protected, manufactured in quantities sufficient to overwhelm opposition through systematic application of material superiority. The final historical irony was that Germans learned these lessons thoroughly, documented them professionally, grasped implications completely, yet could never apply the knowledge gained. Understanding American industrial superiority didn't grant Germany the aluminum, steel, fuel, skilled labor, undamaged factories, and functioning transportation networks needed to produce equivalent aircraft in equivalent quantities. Knowing the P-47's exact capabilities didn't provide high-temperature alloys, precision manufacturing equipment, quality control systems, and trained workforce needed to build comparable turbo-supercharger systems. Intelligence gathered from captured. Aircraft documented dimensions of German defeat with professional thoroughness, without offering realistic path to avoid that defeat. When Allied forces captured Rechlin in May 1945, they found extensive documentation. German technical reports filled filing cabinets, every measurable characteristic of every American and British aircraft examined during the war. The reports were models of technical thoroughness and scientific objectivity. They also represented thousands of man-hours meticulously documenting capabilities Germany could observe and measure but never replicate given deteriorating industrial situation. American technical intelligence teams reviewing German reports noted with professional interest that German engineers understood American aircraft capabilities more clearly and in greater detail than American commanders sometimes did. Germans had identified weaknesses in American designs that American pilots learned to work around through experience. Technical analysis was frequently more detailed and rigorous than equivalent American evaluations of their own equipment. German engineering competence had never been in question, but American reviewers also noted what the reports implicitly revealed about Germany's strategic situation. Germany had attempted to fight a modern industrial war with an industrial base insufficient for the task. They'd compensated through excellent engineering, superior pilot training in early war years, tactical innovation born of necessity. These advantages sustained them through early victories against opponents with similar resource constraints. But against an opponent like the United States, possessing industrial capacity exceeding all other major powers combined, excellent engineering and tactical skill could only delay the inevitable outcome, not change it. The story of German engineers. Examining captured P-47 Thunderbolts provides clear case study in realities of industrial warfare as it evolved by the Second World War. The Thunderbolt succeeded not because it was the absolute best possible fighter by every conceivable measure, but because it was a very effective fighter, produced in quantities making isolated examples of technical superiority strategically irrelevant. American industry built 15,683 Thunderbolts, while simultaneously building 15,486 P-51 Mustangs, 10,370 P-38 Lightnings, 13,738 F-6F Hellcats, 12,571 F-4U Corsairs. Total American fighter production exceeded 70,000 aircraft during the war. Each aircraft represented thousands of hours of skilled labor, tons of aluminum and steel, hundreds of precision components. Manufacturing capacity, Germany could not approach. The P-47 Thunderbolt became a symbol of American industrial dominance to German pilots who fought against it. They used the same nickname American pilots coined, calling it the Jug, in acknowledgement of its ungainly appearance. They also called it Indiana, after the Thunderbird emblem many squadrons painted on engine cowlings. As losses mounted and strategic situation deteriorated, some referred to it simply as that 8-gun fighter. They learned through bitter experience to avoid engaging Thunderbolts at altitudes where the American fighter held tactical advantage, which increasingly meant avoiding combat above 20,000 feet, where the turbo supercharger gave the P-47 decisive performance superiority. By war's end, P-47 Thunderbolts had destroyed approximately 3,752 enemy aircraft in aerial combat. Approximately 3,499 P-47s were lost to all causes, including operational accidents, mechanical failures, ground attack missions. This roughly 1-to-1 exchange rate appears unremarkable until considering that Thunderbolts served primarily in ground attack from mid-44 onward, facing intense anti-aircraft fire during low-level missions rather than engaging primarily in air-to-air combat. In the pure fighter escort role during 43 and early 44, P-47s achieved significantly better exchange rates, particularly at high altitudes where turbo supercharger advantage was most pronounced. The ground attack role revealed another dimension of American design philosophy, emphasizing versatility. When P-51 Mustangs with superior range began taking over bomber escort duties in 44, the 9th Air Force reassigned many Thunderbolt groups to tactical air support. The rugged P-47 with reliable air-cooled radial engine and heavy armor proved exceptionally suited for dangerous low-altitude attack. The same characteristics making it seem ponderous in low-altitude dogfights: substantial size, heavy weight, comprehensive armor, powerful armament, made it nearly ideal for ground attack where survivability and firepower mattered more than maneuverability. Thunderbolt pilots flying ground attack destroyed staggering quantities of German military equipment. Official claims documented through gun camera footage included over 86,000 railway cars, 9,000 locomotives, 6,000 armored fighting vehicles, 68,000 trucks destroyed or damaged. While such claims inevitably included duplication, the scale of destruction was undeniable and had measurable impact on German operations. The P-47, armed with bombs and rockets in addition to 8 machine guns, evolved into true multi-role combat aircraft. German ground forces learned to recognize and fear the characteristic sound of Pratt Whitney R-2800 radials at low altitude. The deep rumble provided warning of impending attacks German troops were largely helpless to prevent. Psychological impact of constant air attack, combined with substantial material losses and disruption of logistics and communications, measurably degraded German ground forces' combat effectiveness throughout 44 and 45. The pilots' fates after capture differed. William Roach spent the remainder of the war at Stalag Luft 1 in Barth, Germany. He was liberated by Soviet forces in May 45 and returned to the United States. Lloyd Hathcock spent 11 months as prisoner of war, primarily at Stalag Luft 3, the site of the famous Great Escape that had occurred 3 months before his arrival. He was the only African-American pilot among thousands of white prisoners at the camp. When Soviet forces advanced westward in January 45, Germans evacuated the camp, forcing prisoners on brutal winter march to Stalag 7A, then Stalag 13D. He was liberated by Allied forces in April 45. Hathcock returned to the United States and played significant role in post-war desegregation of the U.S. Air Force. He, Later, pioneered innovations in aerial reconnaissance photography at Wright-Patterson Air Force Base. Hans Werner Lerche survived the war despite flying 125 different aircraft types throughout the conflict. His remarkable safety record stands unique in aviation history. After the war, he provided extensive debriefings to Allied intelligence about German aircraft development programs. His memoirs, published in '77 in German and translated to English in '80, provide one of the most detailed first-hand accounts of the German captured aircraft evaluation program. The broader lesson transcends specific technical details of one aircraft type. The Thunderbolt evaluation at Rechlin demonstrated that by 1943, the outcome of the air war over Europe was being determined not by pilot skill, tactical innovation, or even aircraft performance in narrow technical terms, but by industrial capacity applied at national scale. The nation that could design adequate equipment and produce it in overwhelming quantities, while simultaneously producing everything else a modern military requires, would inevitably defeat opponents who produced technically superior equipment in insufficient quantities. Germany's situation by late '43 was that of a nation attempting to compete industrially against opponents whose combined industrial capacity exceeded German capacity by factors of 5 or more. When Britain refused to capitulate after France fell, when the Soviet Union survived the initial German onslaught and relocated its industry beyond German reach, when the United States entered the war with its vast, untouched industrial base, Germany's path to military victory effectively closed. The only question was how long Germany could continue fighting and how much destruction would occur before the inevitable conclusion. The story of Beetle and the other captured Thunderbolts at Rechlin becomes microcosm of Germany's broader strategic dilemma. German engineers could examine American equipment, understand American capabilities, accurately assess American industrial strength. This knowledge was professionally gathered, carefully analyzed, thoroughly documented, but knowledge alone couldn't produce the aluminum, steel, rubber, fuel, machine tools, skilled workers, undamaged factories, and functioning railroads required to compete with American industrial output. The Republic P-47 Thunderbolt, examined in minute detail by German engineers at Rechlin, proved a final truth about industrialized warfare in the 20th century. Material abundance systematically applied through competent engineering and adequate tactical execution would defeat technical excellence constrained by resource scarcity. The most powerful element in America's arsenal wasn't any individual technology, however impressive, but rather the complete industrial system that could conceive, design, develop, test, produce, and logistically support thousands of complex weapon systems simultaneously, while maintaining quality and continuously improving designs based on combat experience. The captured Thunderbolts taught this lesson with undeniable clarity. German engineers measured it precisely, documented it professionally, reported it accurately through their chain of command. The lesson arrived too late to matter. By the time William Roach's Beetle was being meticulously examined at Rechlin in late 1943, the outcome of the war was already determined by industrial mathematics that no amount of German engineering skill or pilot courage could overcome. The Thunderbolts, sitting on German airfields, wearing hasty black crosses painted over American stars, represented a future that had already arrived, one in which industrial capacity had become the decisive factor in modern warfare. There's a photograph from May 1945, taken by American forces at Göttingen. It shows Beetle parked among the wreckage of the Third Reich, German crosses fading on its wings, yellow paint peeling from its tail, surrounded by Focke-Wulfs and Messerschmitts that would never fly again. The massive radial engine is silent now. The 8 guns in the wings will never fire another round. But in this image, you can see everything the war had become. A German fighter sits next to an American one. The German aircraft is lighter, more agile at low altitude, in some ways more elegant in its engineering. But the American fighter is surrounded by the evidence of what actually mattered. Numbers. Resources. The capacity to build not just one excellent aircraft, but 15,000 of them, and keep them flying and replace them when they fell. And do it all while building everything else an industrial nation at war requires. The men who examined Beetle in that hangar at Rechlin understood this. They measured every dimension, weighed every component, tested every system. They wrote their reports with scientific precision and professional honesty. And in those reports, between the technical specifications and performance data, you can read the truth they discovered. They weren't just examining an aircraft. They were witnessing the end of their world. Not because the Thunderbolt was invincible. Not because German fighters couldn't compete on any battlefield. But because there would always be another Thunderbolt. And another. And another. Until the sky itself belonged to them. William Roach went home. After the war, he lived a long life. Told his story when asked. Never forgot the moment he looked out his cockpit and saw those black crosses where stars should have been. Hans Werner Lerche went on to become a legend in aviation circles. The test pilot who flew everything and never crashed once. Who treated every aircraft, friend or foe, with respect and professional curiosity. Lloyd Hathcock helped change the United States Air Force. Breaking barriers that should never have existed. Pushing forward when others said it couldn't be done. The Thunderbolt itself became a symbol, not just of American air power, but of a particular moment in history when industrial capacity became more important than individual valor, when the ability to produce thousands of good aircraft mattered more than the ability to produce hundreds of perfect ones, when quantity, properly applied and adequately engineered, became its own quality. There are still P-47 Thunderbolts flying today. You can hear them at air shows. That deep, unmistakable rumble of the R-2800 radial. Feel the ground shake as they pass overhead. And when you see one, remember Beetle. Remember the German engineers who examined it with professional thoroughness and growing dread. Remember what they learned. And remember that sometimes the most important lessons come too late to change anything. The sky remembers, even when we forget.